simulations, all right? So in terms of simulations, we're looking at real life scenarios and how we can use math to be able to recreate scenarios without actually them having to happen. So the stories we're going to look at is like aeroplanes taking off. Without us actually having to go and find the data about aeroplanes taking off, we're going to use our calculators to simulate aeroplanes taking off. Okay? We're going to use our calculators to simulate whether at an intersection you turn left or you turn right because of probability, like saying that 30% of cars turn left at this intersection. By knowing that, we can then make a simulation of that event happening. Okay? The first thing we need to know for simulations is how to calculate random number lists. Okay, so how to be able to use our calculators to pick a random number. The reason we need to be able to do that is, even when we try to find, so say you pick a random number between 1 and 10, Sam? 5, okay? Pick another one. 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 All right. What do you notice about the numbers which Sam just picked out? They're all different. That because he wants them to be random in your head, and that means they have to all be different. But a random number generator is going to make it the same, make a random pick every single time, and so you might get the same number 3 times. Okay? When we try to be random in our brains, we actually try to put it in an order without even meaning to. While a calculator, a random number generator, just picks a random number each time. So that's why it's really good to use our calculator. Okay? So we need to be able to use random numbers to do simulations. Okay? So we use, sorry, it's okay. We use random numbers to do simulations. You may as well, since that's what I usually ask you to do. All right? We use random numbers to do simulations. Your calculator has a random number generator. Random number generator. So as I said, it's much better to use a calculator because it truly is random. When we try to be random, it's not actually random. All right, so where we find this is in our calculators. We need to go to the catalogue, which is where it says, so let's go open up your keyboard in main. Open up your keyboard. I'm just going to clear all. You open up your keyboard and go to catalogue. CAT. That's what CAT stands for. Okay, we're right. Not needed. All right, so when you open up your keyboard in main, you should have catalogue somewhere. Then yours might be a bit different. Okay, keep looking for catalogue, please. Okay, so just as a reminder, we go main, we open our keyboard, and we go to catalogue, and I want you to go to R, catalog, and then go to R, which should come up with round list, etc. Sorry, it will be back. It's coming back.
Should be more. Touchscreen's messed up.
Can you show me yours? Yeah, but this is because your calculator's still broken. I can't even press anything even if I could. Where did you go?
There's an arrow.
Okay, so in math. Okay, I can't even click that button. I think it's in math. You have to get a new one. Can you go sit next to someone who's here? Face the wall. That's gonna be great on the YouTube thing, hey. Anyway, so main keyboard catalog R. So Zen, do you just want to go sit next to not him, someone around the place, yeah? All right. So once you get to R, you need to use the arrow to get there. You should get this list of different things. Later on, you can just sort of copy and paste them. You don't have to keep going to catalog. You need to go to R. It's in alphabetical. All right. Click on R first. That'll be easier. All right. We have two different things we're going to use. We're going to just use rand, and then we're going to use rand list. Okay? So we're going to start with rand. If we go rand, and we click input, because that puts that in there. Once you get used to this, you can use your typewriter, like your ABC, to just write rand bracket if you want as well. You don't have to always go to catalogue, or you can just copy it and drag it and things like that. Okay, so rand tells us we want to pick one. It picks one number for us, and we just need to tell it what numbers we want to have it between. So what numbers do we want to pick a random number between?
1 and 15.
1 and 15. So I would go that 1, 15 and close the bracket. And then press execute. It gives me a number, 11. If I click execute again, 9. 13. Yours will be different. Anyone, do it 5 times. Anyone get to repeat? Yeah, okay. See, so it doesn't, repeats don't mean it's not random. Okay, it doesn't mean it's random either. It just means that it's just always that way, okay? All right, so rand, bracket, number, comma, number, okay? This picks one number one random number between the set parameters. What's parameters mean? Let's not write parameters, let's just write between the set numbers.
When you say the set numbers, are they inclusive?
Yes, good point. Inclusive. Very good point. Everyone okay with using rand? Great. Okay. What about a rand list? What do you reckon that means? Yeah. A rand list gives us a list of numbers between the set parameters. Okay. So rand list has 3 parts to it. A number, a comma, a number, a comma, a number. What do you reckon one of those is? Why do you reckon there's an extra one? Good. How many numbers you want to pick. Okay, so the first number is how many numbers, how many results you want. That's better. How many results you want. So if I wrote here 8, it means I want to find 8 random numbers. Between, what number should we look at? Between 7 and 98. Okay, so this is a list of numbers. We would want a list of 8 numbers between 7 and 98 inclusive. Can you guys try that out on your calculator, please? So usually rand list is a lot easier to use and more often used than just a random number, because then you usually need a few numbers in a row. But either work to find a number. Everyone okay? All right. Why do you think we might need to pick random numbers when I'm talking about simulations? Say again? Yeah? Okay, what else? I guess if you get told that there's a 30% chance that something's going to happen. So if there's a 30% chance that Mr. Banks will walk through the door next, okay, you get told that. Then you can actually go, well, if there's a 30% chance, I could go, well, let's do a let's each lesson or something. I could use a random number generator to go, okay, if I go numbers between 1 and 10, if 1, 2, and 3 means Mr. Banks walks through the door, 4, 5, 6, 7, 8, 9, 10 means he doesn't. We could then get a random number generator and it might come up with, let's actually do it, hang on. Josh, not needed. So if I say 1 and 10 and I want to, so today, what's the chance that he's going to walk through the door? It says 3, what's going to happen? He's coming through the door. Okay, it doesn't mean that he actually is, but in our simulation he has. Tomorrow I do the same thing. Did he walk through the door? He did. Okay? Because 1 to 3, 30% chance out of 10. Okay? 1 to 3 meant that he walks through the door. 1 to 3 means he walks through the door. 4 to 10 means he didn't. What about the next day? He didn't come in. What about the next day? He didn't. What about the next day? Next day. Sorry, lost it. Okay, but can you see how I can, if I have a real percentage, because there's not 30% chance he's going to walk through that door, but if I had a real percentage, if I had some data to back me up, and I said, okay, there's a 1% chance of something happening, I can then use number generators to go, okay, let's simulate that. Let's see if it would happen tomorrow, the next day, the next day, the next day. Now, if it was a 1% chance, what would our range of numbers be from? What would be the easiest thing to do? Say it again? We'd want to have 1 to 100. Okay, and then the number 1, or whatever number you pick, it might be your favourite number. Number 19 counts as yes, and the rest are all no's. Things like that. Can everybody see that? Yeah. All right, let's do an example which is on your sheet, okay? And I'm sorry to the people who did 2CD last year, we've already done this sheet before. But there aren't that many simulations questions, all right? So this sheet I've given you, is anyone missing it? This sheet I've given you has questions which have been in the last few tests, okay, and exams. They're pretty much the only questions which have been in the last few tests and exams. So what do you reckon will be in your test? Something very similar to these. So we're going to make sure that you know how to do them all right, because they're all very similar. Okay, so let's have a look at this seeding question. The Australian tennis, hang on, I'll just write down. So question 1, tennis. All right, the Australian Tennis Open uses in part a seeded knockout competition. When competition moves into the quarterfinals, that is, the last 8 players, it is known from historical records that for any given match, the highest seed wins 70% of the time. So, tennis players are seeded. Number 1 is the highest seed, yeah? And it's saying that from the records, it shows that if you're playing in the quarterfinals, the person who is the highest seed has a 70% chance of winning. Does that make sense? Max? Yes, good. Use the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and describe how you can simulate the final 3 rounds to determine the winner of the championships in this simulation. So if we're saying 70% chance of winning for the top seeds, what would we do to be able to do this? How could we use the numbers 1 to 10 to simulate this? Yeah? 8, 9 and 10?
Oh, yes.
Yeah. So what we could then say is 1 to 7 means top seed wins. Because if we pick a number between 1 and 10, 1 to 7, if we allocate 1 to 7, being the top seed wins, and then 8 to 10 means what? Lower seed wins. All right? Any simulation, you must show what you're doing here. You must show what the random numbers mean, because it's a simulation. It's not real. We're actually just trying to try it out, see if we can work it out. And this is what people do in like footy tipping and all those sort of things. It's similar. There's certain percentages in terms of home games, in terms of streaks, in terms of all those sort of things. And that's how a lot of these sort of things happen. Like how we do predictions in the future is through simulations. All right? Pardon? Maybe. That's it, because supposedly when they're on a streak, they keep going on a streak, is what I've heard. All right. So, if we look at this, we're then going to do an experiment. But in your test, why do you think we can't make you use your random list to start with? Because everyone will have different answers and you'd have to actually explain it. So instead, it says use the list of random numbers generated using the ClassPad function shown on the screen capture below to determine the winner of the championship. So this way you've all been given what it is. So you just need to know that rand list exists and what it is. So on here it says rand list 7, 1, 10. What did that mean? Yeah?
There was a list of 7 numbers from 1 to 10.
Perfect. We've given you a list of 7 numbers from 1 to 10. So the first number was 10. Now, the first, I have to draw it. The first competition was seed 1. I'm just not going to write their names. Seed 1 versus seed 17. Now, if we rolled a number 10, who won? Number 17, because the bottom seed won. Serena got knocked out. All right. Next one. Pardon? Yeah? Yes, so that's why we had that first question there, because we'd have to give you follow-through marks for that. So you could do it the other way if you wanted to as well, and we'd still mark you that way. All right? Okay, next one was seed 8 and seed 10. Seed 8 and seed 10. What number came up on the random number generator? 1. What does 1 mean? Seed 8, 1. Yeah? All right, next one. Is it 7, 11? 7, 11. And what did we come up with on the random number generator? 4. What does 4 mean? 7, 1. Can everyone see how we do this? Yeah? Good. All right, last one. Seed 2 and seed 12. And what number came up? Number 8. So who won? 12. Yes. So you could either do it on your calculator, but it tells you on there. See how it's got that random list of numbers? They're the numbers you have to use. So it's done it for you. Okay? So the next one, 17 versus 8, and we got a number 5. So who does that mean won? Seed? 17 or 8? 8. That's right. All right, and then 7 versus 12. 7 versus 12, it came up with a 1, so 7. And then, now, I'll just give you a tip right here. Last year what we did with this was that we actually gave people like different tests, so they had different winners. So we might do that again, and people might have different tests. Same concept, different winners, so just so people have to try things out themselves. Yep, we've only got one class though, so we might not. All right, last number. 5. So who won? Number 7, who was Angelique Kerber. Alright, winner. Can everybody see what we did there? Yeah? Can you understand that this is actually quite simple as long as you understand the idea of the using numbers for results? Yeah? Actually doing it is really easy. It's just the getting the numbers right. Alright, let's have a look at question 2. This question was in a exam a couple of years ago. I think it's quite challenging. I think I'd probably put it in a test or exam. Alright. Okay, let's have a look at it. A student made a spinner in the shape of a regular octagon and marked it with the letters A and B as shown. How many A's are there? 5 A's. How many B's are there? Yeah, so 5 A's, 3 B's. Just because I don't have the question, I was writing down. The student then simulated the experiment using a list of 50 random digits shown here. Let the digits 1, 2, 3, 4, 5 represent A. 1 to 5. Let the digits 6, 7, 8 represent B. Ignore the digits 0 and 9. Alright, now what seemed to happen with people in this question in their test or their exam was that they looked at it, and because they were set up in 5 digits, 5 together, they sort of tried to put that together. They went 6, 2, 8, 7, 4. And they went, oh, I don't know what to do, and they sort of left it. Okay? But each digit means something. So what does 6 represent? It represents B. Okay? So it just means that B was spun then. What does the 2 represent? A. So A was spun then. What does the 8 represent? B. 7, 4, 1, 8, 9. Nothing. So you need to get rid of the 9. So the first thing I would do in this is go through and get rid of all the 9s and all the 0s because you don't need to look at them. It says ignore them. Nick, can you just go put the gum in the bin, please? Alright, so we need to get rid of all the 9s and all the 0s. So I'm going to actually get rid of them. Because we have to ignore them. So for you guys, you just like cross them out. Have I missed any? Alright. So, first question says, how many B's were spun in the first 5 simulations? First 5 simulations are these numbers. B means 6 to 8. How many 6s to 8 were there in here? 1, 2, 3. So the question was, there's 3 B's in the first 5. The answer was 3 B's in the first 5 simulations. No, just write 3. I'm just writing it like this so that people can see it if they want to. In the first 5 simulations. Make sense? Yeah? And that's why we actually say, like, first 5 simulations, we're trying to show you that that block is just 5 simulations. Okay? Next one says, how many simulations are possible with the list of random numbers shown? How many are there? Why is it 42 only? Because we took away 8 zeros and 9s. Okay? So 42 possible simulations. All right. See, that again is trying to make sure that you understand what's going on and that you take out the zeros and the nines. It's guiding you how to answer this question. Part C says, use the list of random digits to simulate the experiment and use your results to determine the percentage of simulations that the spinner stopped on a B. So, how many Bs were there? 17. So, how can we work out our percentage? 17 over 42 times 100, which is? Oh. Oh, 40.5% to one decimal place. Can everyone see what we did? How simulation gave us an answer? Yeah? You had to do a percentage, yeah. You don't write 41 or 40, you always put in a decimal. And just show where you round it to. Any questions to there? All right, can we go on? I'm sorry it's a very long lesson of talking, but I think it's important that we go through all the different types. All right? Thanks, Nick. So, question 3. Can we move on? Adam, do you have a question? You're okay. Sure? All right, question 3. Says, a motoring club is planning an event and wants to know what its members would like. They plan to ask 80 members, chosen at random from the total membership of 685 people. So they have 685 people. They want to pick 80 members. An extract from a table of 3-digit random numbers is shown below. Choose one of the numbers from the list and explain how the club could use it to select one of its members. Yep. So you're going to allocate each person a number. And any numbers over that number don't count. Yep. So 940, would we use 940? No. Which numbers would we use? 279. What would that count as? A person who's part of the club. Perfect. Okay. So choose one of the numbers from the list and explain how the club could use it to select one of its members. So which one could we pick? 109. Okay. Are they going to be... So they plan to ask 80 members chosen at random. So we'd pick them out and would say, okay, number 89, sorry, 109 is picked, right? So you'd go through this and you'd say, okay, would 940 be picked? No. 517? Person 517 is going to do the survey. Person 279? Yes. Person 109? 794? 984? And so on. All right, so it says choose one of the numbers from the list, explain how a club would use it to select a member. So you might say 517. The person 517th on the list would do the survey. That's worth 2 marks. Pretty easy. Okay, then it says how many numbers in the above list could be used to select a sample. How many would there be? 1. Oh, okay, so we can't use it twice. Good point. So how many would we use? Pardon? 79 of them. How many, Alex? 5 of those lists. 5 people in the list could be chosen. Okay, because the rest, and you needed to justify why, that's only worth 1 mark. Because the rest are above Yep, good. Are above 685 or repeated. Can everyone understand? All right, can we do the last one? All right, can you guys just read the question to yourself quickly? Actually, I'm going to leave question 4 to you to do yourself. So, homework. Question 4, and you could do that right now. We might go through it if we have time. Homework, question 4, plus. Glad you're excited. Page 112 and 115, which is really just one question revisited. So page 112, it's called overbooking, and 115, overbooking. It is about aeroplanes. All right? Could you get started on question 4, please? You could probably get all of this done before the bell goes. Hang on a sec.